BGP Advanced Aggregation with AS Set option. In this video, I'm going to talk about some features, some behaviors of the aggregation, and after that, I want to talk about AS Set feature. First, we should understand aggregation in BGP more and more. After that, we can check the AS Set option in the BGP aggregation command and its effects. Okay, look at this scenario. In this scenario, we have three AS. First AS is AS 65000, second AS 65001, and the third is AS 65002. From AS 65000, R1 should send its routes to the R3 with BGP update, and also R2 should send its BGP update to R3, and after that R3 should send these routes to the R4. Here in R3, I want to aggregate these routes. This is the proxy aggregation. The proxy aggregation means the aggregation occurs in other routers than the originator router. Okay, look at here. This is the proxy aggregator. Proxy router or proxy aggregator. This means that R1 is the generator of the routes and R2 also, but R3, for example, R3 is an ISP router, should aggregate the routes received from R1 and R2. R1 and R2 may be in a customer and R3 in a provider. Provider should aggregate the routes received from the customers and then advertise to the upper ISP or other, or for example, internet. This is the proxy aggregator definition. But in the proxy aggregator, when we are using proxy aggregator, one important thing that we should understand is the behavior of AS-pass attribute. What is the AS-pass behavior? This means that when, for example, you receive a route from the R1 and also R2, and you want to aggregate these routes, the change in the AS-pass attributes, how does occurs? Okay, look to this scenario. Look at here. For example, we have R1 and also R2. Okay, R1 should send an update to BGP to router 3 with BGP update 1100/24, and also R2 should send this update. Look at here, 1100/24, and these routes received by the router R3. Now R3 as a proxy aggregate or proxy aggregator want to aggregate these routes and should send, for example, 1100/23 to the R4. Okay, you know that in the update that R3 received, beside of the NLRI, also pass attributes such as AS-pass attributes exist. For example, AS-pass here is 65,000, and also in the R2 also sets to 65,000 because both of these routers, R1 and R2, in AS 65,000. The first question is that when R3 aggregates these addresses as a proxy aggregator, how does it change the pass attribute? It's the first question. I want to first answer these questions, and after that we can check the AS set function result. Let's configure this scenario and experiencing all of the topics that I want to talk about that in this video. Look at here. In R1, we should configure all of the things in R1. So easy, conf-t. Host name is R1. Again, interface ETH00, IP address is 10.1.10.1.3. Look at here. I want to change this IP address 10.1.3 because this links between router 1 and router 3, and this is 10.2.3. It's okay, but this link is this link's IP address is 10.3.4.0. It's better. Okay, look at here. We have configuration here in R1. R1 interface ETH00 10.1.3.1 255.255.0 and no shutdown. Also interface loopback 0, IP address 1101.255.255.255.0. This is the configuration of R1 first. Then R2 en conft hostname R2 interface ETH00 IP address 10.232.255.255.255.0 and no shutdown. Interface loopback 0 IP address 111, for example 1, or maybe you can use 1112 because it's in the router 2 1112.255.255.255.0. okay, and this is the configuration of R2. Now we should go to R3 en conft hostname R3 first interface ETH00 IP address 10.133.255.255.255.0 no shutdown. Interface ETH01 IP address 10.233.255.255.255.0 and then no shutdown. Finally, interface ETH02 IP address 10.3.10.3.4.3.255.255.255.0 and then no shutdown. Okay, so easy. And finally R4 in R4 en conft hostname R4 then interface ETH00 IP address 10.3.4.4.255.255.255.0 and then no shutdown. Okay, this is the configuration of R4. Let's configuring the BGP from R1. Router BGP 65,000, neighbor 10.133, remote AS 65,001. And also R2. Router BGP 65,000 and then neighbor 10.233, remote AS, for example 65,001. And finally R3, router BGP 65,001, neighbor 10.131, remote AS 65,000, and then neighbor 10.232, remote AS 65,000, and also neighbor 10.344, remote AS 65,002. This is the R4. Finally, we should go to R4, router BGP 65,002, and then neighbor 10.343, remote AS 65,001. Now we can check all of the BGP neighborship from R1. Let's start from the R1. Show BGP IPv4 unicast summary. In R1, we have neighborship with router 3, state is established, and then R2. Show BGP IPv4 unicast summary. You can see that state is established with router 3, and then R3. Show BGP IPv4 unicast summary, and we have 3 neighborship with router 1, router 2, and also router 4. All of the states are established. Finally, R4. Show BGP IPv4 unicast summary. R4 is also as neighborship with the router 3. Very good. Let's import or inject the R1 and R2 routes into the BGP table of them. Conft in router R1, router BGP 65,000. Please inject with network command. Please inject network 1100 with the mask of 255.255.255.0, and then go to R2, conft router BGP 65,000. Please inject network 1110 with the mask 255.255.255.0. Now in R1, do show BGP IPv4 unicast shows us that we have one injected routes, and also in R2, show BGP IPv4 unicast, we have one injected routes, and also R1 and R2